Welcome back to ChemDetective. Today, we're diving into IR spectroscopy ranges and learning how to quickly spot different functional groups in a molecule. The absorption information is presented in the form of a chart called a correlation chart. Every functional group has its own IR fingerprint, learn the ranges, and the spectrum speaks for itself. How to approach the analysis of spectra? When analyzing the spectra of unknown compound, concentrate first on determining the presence or absence of few major functional group. Carbonyl, triple bond, double bond, cyano and nitro peaks are the most conspicuous and give immediate structural information if they are present. First, look if carbonyl group is present. Carbonyl group gives strong absorption in the region 1820 to 1600 per centimeter, peak is strong and medium width. If present, check for the presence of the following groups: acid, amides, ester, anhydrides, and ketones. If absent, check for the presence of the following groups: alcohol, phenols, amines and ether. Second, look for double bond or aromatic ring. C double bond C is a weak absorption near 1650 per centimeter. Medium to strong absorption in the region of 1600 to 1550 per centimeter indicates it is a aromatic ring. Confirm the double bond or aromatic ring by consulting the C-H region. If C-H stretch occurs to the left of 3000 per centimeter, it is aromatic or vinyl. If C-H stretch occurs to right of 3000 per centimeter, it is aliphatic. Third, for triple bond, C triple bond N is medium sharp peak near 1150 per centimeter. C triple bond C is weak sharp peak near 2150 per centimeter. Check also for acetylene C-H near 3300 per centimeter, which gives an idea if triple bond is placed terminally. Lastly, nitro groups shows too strong absorption at 1600 to 500 per centimeter and 1390-1300 per cm. And remaining are all hydrocarbon. Let's quickly compare IR ranges of alkanes, alkenes, and alkenes. Alkanes, look for sp3ch stretch around 3000 per centimeter and bending around 1470 per centimeter. Alkenes, sp2ch stretch appears just above 3000 per centimeter, with C double bond C stretch, around 1600 per centimeter, plus diagnostic out of plane bends around 1000 per centimeter. Alkenes, sharp sp-CH stretch at 3300 per centimeter, and a C triple bond C stretch around 2100 per centimeter. For benzene, C-H stretching, 3000 to 3100 per centimeter. C double bond C stretching, 1500 and 1600 per centimeter. These are the signature peaks for the aromatic ring. For monosubstituted benzene, peaks at 690 to 710 per centimeter and 730 to 770 per centimeter. Perfect for spotting a single group attached to benzene. For orthodisubstituted, sharp peak at 735 to 770 per centimeter. Two groups next to each other? This confirms it. For metadisubstituted, peaks at 690 to 710 per centimeter, and 810 to 850 per centimeter. Lastly, for disubstituted benzene, peaks at 810 to 840 per centimeter. A broader region. Great for identifying multiple substitutions. These fingerprint regions help you easily identify the substitution patterns on the benzene ring. Example. Spectrum of hexane, 1-hexene and benzene. Let's compare aldehydes and ketones by their IR peaks. Aldehydes. CO stretching, 1740 to 1720 per centimeter and CH stretching, 2900 to 2800 per centimeter. The aldehyde group has both carbonyl and CH peaks, key for identification. Acids versus alcohols versus phenols. For acids, O shows 3400 to 2400 per centimeter, a broad peak plus CO stretch 1725 to 1700 per centimeter. For alcohols, O shows 3600 per centimeter, sharp peak. No CO stretch. For phenols, O shows 3400 per centimeter with aromatic C double bond C. That's how you easily spot acids, alcohols, and phenols in IR spectra. And that's it for today's session on IR ranges. Don't forget to subscribe and stay tuned. In the next video, We'll continue exploring more IR ranges to make functional group identification super easy. See you there.